when we're dealing with circles, it's the size of the angle in a circle that makes the radius and arc length equal. So we know what a radius is. It's the distance from the center of our circle to the edge. Arc length is something we have not really talked about before. And arc length is the distance on the outside of the circle. We use the variable s to stand for arc length. So my angle is in there. So what this definition says is if the length of S is equal to the length of R, then your angle is equal to 1 radian. So what this tells us then, in general, if I want to find the measure of the angle, we are just going to do the arc length divided by the radius. This is a formula we will use more later in the chapter, but it's good to go ahead and talk about now. So if you know the length of the arc length, it's basically your angle is how many of the radius is that? How many radii would it take to make that arc length? So let's look at an example. Now you don't necessarily have to write this down word for word. Let me read it, and then if you want a shorthand of what to write down, I can show you. Essential angle theta in a circle of radius 3 centimeters cuts off an arc length 6 centimeters. What is the radian measure of theta? So if you're writing this down, you don't want to write the full question. Your radius is 3 centimeters. Arc length, that's your S, is 6 centimeters. We need to find theta. Okay, so all we have to do is, we just said that theta equals S over R. Our arc length was 6 centimeters. Radius is 3 centimeters. What happens if you take centimeters divided by centimeters? What happens to that label? It cancels. That's why I said radians don't have a unit. Okay, so just 6 divided by 2 is 2. So theta equals 2. You could say 2 and write the word radians if you wanted, but most of the time I won't. So anytime I see something without a degree symbol, I am assuming it is radians from now on. Is that okay? Alright, we have these two measures. We have radians and we have degrees. And if we're going to have two different measures, we need to be able to go back and forth between the two. So this is going to explain to us how to convert, where this conversion factor comes from. So let's say I have an angle formed by a full rotation. In other words, you go all the way around the circle. the formula I gave you is that theta is equal to S over R. S is arc length, the distance around the outside of the circle. So if I go all the way around the circle, what's another word for a total distance on the outside? Well, that's in degrees. We'll get there in a second. Not even trig related. What's the distance around the outside of a circle? Circumference. Do you guys remember how to find circumference? Circumference is 2 pi r. So in this case, since the arc length, the S, is the entire distance around the outside, that is the circumference, and the formula for that is 2 pi r. So my S is 2 pi r divided by r. What's going to happen to those r's? They cancel. Okay, so what that means, all the way around the circle, in degrees, we said is 360 degrees. And we just found that in radians, all the way around the circle is 2 pi. So if you divide by 2, 180 degrees is equal to pi radians. That will be what we use to convert. So we're going to just do some examples, converting back and forth between the two. If I want to change 45 degrees to radians, okay, we've done some conversions before, haven't we? If I said, like, you have 20 minutes and I want you to change it into seconds. You know, remember setting up like 20 minutes times, or 60 seconds equal to 1 minute, setting problems like that. So that's really what we're doing here. I have degrees. I have my 45 degrees. If I want radians, I want my degrees to cancel. So the degrees need to go on the bottom. And I know 180 degrees is equal to pi radians. You can write the word radian, but you do not have to, and I usually will not. So when we do this, the degrees cancel. So you have 45 pi over 180. If you're using a calculator, don't put the pi in, just do 45 over 180, and that gives you 1/4, so this is just pi over 4. That one okay? Next one. Change 450 degrees to radians. Okay. So 450 degrees, I want to cancel the degrees, so those go on the bottom. So pi radians goes on the top. Grab your calculator, don't put the pi in, just do 450 over 180. What does that reduce to? 2.5. Change it to a fraction. So we'll say 5 pi over 2. You can say 2.5 pi. I just usually go with fractions. Alright. Sometimes sometimes I will have you go ahead and multiply out the pi. If it's an example like this, you'll notice my angle is already a decimal. So usually if you already have a decimal, I'll tell you go ahead and multiply in the pi as well. You also see I asked for you to round to the nearest hundredth, so I'm asking for a decimal here. So negative 78.4 times pi over 180. So those degrees cancel. I want you to just put everything in the calculator. Do not do 3.14 for pi. Use the pi button on the calculator. So multiply by pi and divide by 180. Hundredth is how many decimal places? 2.
Where is the pi button?
And the exponent button, if you hit second and then the little exponent. The mode actually will not matter. Mode is only going to matter if you use the sine, cosine, or tangent buttons. Otherwise, it won't make a difference. Good question. Alright, so far so good? Everybody get that? What if I gave you pi over 6 and told you to convert that into degrees? So I gave you the radian. And I want degrees. What would I do? Multiply by what? Over pi. You just flip your fraction. 180 degrees is equal to pi radians. So whatever you want to cancel goes on the bottom. So my pi's drop out. I have 180 over 6, which is 30. And you have to put your degree symbol. Okay. Couple more. 4 pi over 3. What would I multiply by?
180 over pi.
And those pi's cancel out. So 4 times 180 divided by 3 is 240 degrees. You need the degree symbol. Now don't get caught in the trap of assuming if it's a radian it will have a pi in it. Most of the time it does, but it doesn't have to. How do I look at a number and know it's a radian measure? There's not a degree symbol. Okay, so whether or not it has the pi doesn't make a difference. So if I said convert negative 4.5, there is no degree measure, so that is radians. I want to change it into degrees. So what would I multiply by? Over pi. I want my radians to cancel, so the radians go on the bottom. I am asking you to round to the nearest tenth, so we're going to put everything in the calculator. So negative 4.5 times 180 divided by pi, using the pi button. I get negative 257, nearest tenth is 1 decimal, and you need a degree symbol. Any questions there? I want to talk about the circle now. Okay, this is what is called a unit circle. This is a circle that basically sits on the XY axis. So the horizontal and vertical line, that's like an XY axis. It's like a radius of 1. So if you took those points and drew a circle connecting them, that's how I created this circle. Today I want to focus on putting the degree and radian measures on this circle. Okay. Eventually we will add ordered pairs to that, but not for a couple sections. If we start This is our 0 degrees. And then our degrees are the hand trick. So we have 0 degrees, 30 degrees, we're doing these common ones, 45 degrees, 60 degrees, 90 degrees. Okay. I'm going to jump down here for a minute. What would this line represent? 180 degrees. Now, these are reference angles. So this one up here has a reference angle of 30. So if you did 180 minus 30, we get 150. The next one is the reference angle of 45. So 180 minus 45, 135. Next one, 180 minus 60 is 120 degrees. In the third quadrant, how would I get these angles? You add your reference angle. So this one right here is like a reference angle of 30. So 180 plus 30 is 210. This would be a reference angle of 45, so 180 plus 45 is 225. Reference angle 60, 180 plus 60 is 240. What would this line represent? Okay, 0 is the same as if you went all the way around 360. We are going to do some quizzes over this circle. I'll just be giving you blank ones and having you fill them out. I don't care if you call that 0 degrees or 360 degrees. You have to have one of them, but not both. How would I get these angles? Subtract your reference angle. So 360 minus 30 is 330. 360 minus 45 is 315. And 360 minus 60 is 300 degrees. Any questions on how I got my degrees? Notice as you go around your circle, your degrees get larger. 0, 30, 45, 60, 90, 120, 135, 150, 180. So you can do that when you're filling out one on your own. When you're filling out one on your own, make sure you do a quick check at the end that they are in order. That will help you if you accidentally flip something. Now let's talk about radians. So to get your radian, you take your degree times pi over 180. That's what we've been working on. 0 times pi over 180 is just 0. 30 times pi over 180. So 30 over 180 reduces to 1/6, so it would be pi over 6. 45, we already did that one as an example, but just remember we did 45 times pi over 180. 45 over 180 reduces to 1 over 4, so it's pi over 4. 60. 60 times pi over 180. 60 over 180 is 1 over 3, so that's pi over 3. 90 times pi over 180. 90 over 180 is 1/2, so that's pi over 2. Okay, I could give you a couple minutes and you guys could finish this, right? You just keep multiplying by pi over 180. But if you're going to do this as a quiz, you want it faster. We don't want to have to sit and do that for everything on the circle. So today I'm talking about some of the patterns that we're going to see. We know 180 degrees is the same as what? Pi. We've been doing that conversion, so we know this is pi. Okay, think about how we got our degrees. I did 180 minus 30. if you're dealing with radians, that would be pi minus pi over 6. So pi, that's like 6 over 6, minus 1 over 6 would give us 5 pi over 6. You guys see what I did there? Pi minus pi over 6. Think about getting a common denominator. So this one, we did 180 minus 45. So we're going to do pi minus pi over 4. So that's like 4 pi over 4 minus 1 pi over 4.
Why are we subtracting pi?
Think about how we did the degrees. Like we did 180 minus 45. So I'm working with the radians now. 180 degrees is pi minus 45 we said was pi over 4. So I'm just giving you a couple different ways of getting these. For the next one, we subtracted 60. So if I did pi minus pi over 3. So 3 over 3 minus 1 over 3 is 2 pi over 3. How did I get the angles in the third quadrant? We added your reference angle, right? We did 180 plus. So we're doing pi plus. So pi plus pi over 6. So 6 over 6 plus 1 over 6 would be 7 pi over 6. Pi plus pi over 4. So 4 pi over 4 plus 1 pi over 4, 5 pi over 4. Pi plus pi over 3. So 3 over 3 plus 1 over 3 is 4 pi over 3. Pi plus pi over 2. 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. Okay, this fourth quadrant. We got those by doing 360 minus our angles. 360 is the same as 2 pi. So again, for the radians, you could call it either 0 or 2 pi. I don't care. You don't have to put both. But we're going to do 2 pi minus these. So like 2 pi minus pi over 6. So that's like 12 over 6 minus 1 over 6. Get 11 pi over 6. Okay, for this one we subtracted 45. So 2 pi minus pi over 4. So 8 over 4 minus 1 over 4 is 7 over 4. 2 pi minus pi over 3. So 6 over 3 minus 1 over 3 is 5 pi over 3. Okay. I want to point out something. Do you have a question?
Yeah, I was gonna ask if the other way to do it, like where you multiply pi over 180, that'll work for the whole circle.
So ultimately, you're going to have this quiz a lot. Basically, I'm going to start giving you quizzes until we all have it. The first few times I give it to you, it's going to probably take a little bit. By the end, I have some people that like this circle so much they ask for a blank one on every test and they can fill it out within 2 minutes. Okay, so repetition, we're going to get there. We are going to fill it out again tomorrow as a class and talk more about the patterns. But I want to point out a few things. If you look at the first quadrant, we have pi over 6, pi over 4, pi over 3, that pi over 2. What do all those have in common? Right, the top is just pi, right? The denominator gets smaller as we go up. But essentially, if it's in quadrant 1, the numerator is just a 1 pi. So pi over each of them. Thank you. Second quadrant. If I'm looking at those, compare the numerator and denominator. You have 5 over 6. 3 over 4, 2 over 3. How's that related? It goes down. The top is 1 smaller than the bottom. So in the second quadrant, it's less than 180 degrees. The numerator is 1 smaller than the denominator. Okay, let's look at the pattern for the third quadrant. In the third quadrant, we have 7 over 6, 5 over 4, 4 over 3, 3 over 2. It's 1 bigger than the bottom. Okay, fourth quadrant, it's a little less obvious. 11 over 6, 7 over 4, 5 over 3. If you take the bottom times 2 and subtract 1, it's like double minus 1. So 12 minus 1 is 11. 8 minus 1 is 7. 6 minus 1 is 5. You guys see that? So each quadrant really has its own little pattern. Also, I want to talk about another pattern here. These angles right here were all reference angles of 30. And what do you notice about the denominator on all of those? If your reference angle is 30, it's always going to be over 6. When our reference angle is 45, the denominator is always 4. When our reference angle is 60, the denominator is 3. Okay, so lots of patterns going on here. Tomorrow I'll probably start class just by filling this out again, but trying to do it with some of the patterns. Okay, but we will practice this a lot. I just wanted to kind of make you aware of some of those now. Do you guys have any questions? Let's look at some problems. Alright, so on our test, we had questions like the sine of 30 degrees, the cosine of 210 degrees. I'm still asking those, but now I might give it to you in degrees, or I might give it to you in radians. And we have to be able to answer it each way. It's just asking the same thing. When I look at this, right now you may need to kind of tell yourself, pi over 6. Okay, my denominator is 6, so I know that is 30 degrees. If you look at the circle we just filled out, we can see pi over 6 and 30 degrees. They are the same thing, it's just different units of measure. So this is just asking me for the sine of 30 degrees, which is, use your hand trick, sine of 30, radical 1 over 2, is 1/2. So your answer, the same values are true. You're not memorizing new values for sine, cosine, tangent. The hand trick still works. But I might say 30 degrees, I might say pi over 6. I might say 45 degrees, or I might say pi over 4. And you have to be able to answer either way. Let's do this one. 4 times the sine of 7 pi over 6. Alright, when we did these on the test, if I asked you to evaluate sine of 7 pi over 6, what did I make you write down? Quadrant and reference angle. That's still true. The quadrant If you're familiar with those patterns, it's not too bad. The numerator is 1 more than the denominator. What quadrant does that happen in? Quadrant 3. Reference angles are really easy to pick out on these because it's just based off the denominator. Pi over 6 is always talking about 30 degrees. So you can write pi over 6, especially right now if you're not quite comfortable with those. You can say 30 degrees if that makes you feel better to see that degree measurement. In quadrant 3 is sine positive or negative. Negative. The sine of 30 degrees is 1/2. So 4 times negative 1/2 is negative 2. Alright, I'm going to put a few up here that I want you guys to try. Alright, so 3 pi over 4. If the numerator is 1 less, that's quadrant 2. Reference angle, I told you basically just ignore the number on top, so it's just pi over 4, which if you think about it is 45 degrees. That helps you. In quadrant 2, all students, sine is positive, so tangent would be negative. Tangent of 45, radical 2 over radical 2 is 1. Okay, number 2, 5 pi over 3. Quadrant 1, the numerator is just pi. Quadrant 2, the numerator is smaller. Quadrant 3, it's 1 bigger. Quadrant 4, it's double minus 1. 3 times 2 is 6, minus 1 is 5. So this is quadrant 4. Reference angle, you just basically ignore that 5. It's pi over 3, or 60 degrees, if that helps. In quadrant 4, all students take calculus. Cosine is positive. Cosine of 60 is 1/2. Number 3, secant of 2 pi over 3. What quadrant is 2 pi over 3 in? Quadrant 2, the numerator is 1 more. Reference angle is just pi over 3, or 60 degrees. In quadrant 2, all students, sine is positive, so secant, that's the reciprocal of cosine, would be a negative. Okay, to get secant, I'm going to think about cosine for a second. Cosine of 60 is 1/2, so secant is negative 2. And the last one, cosecant 11 pi over 6. What quadrant is 11 pi over 6?
4.
Reference angle?
30.
Yep, pi over 6 or 30 degrees. In the fourth quadrant, cosine is positive, so cosecant, the reciprocal of sine, would be a negative. Sine of 30 is 1/2, so cosecant would be negative 2. How do we feel about those? One last question, last one of the day. So it's more along those lines, just got an extra step to it. For sine 2x plus pi when x is equal to pi over 6. Okay, so if we plug in two times pi over 6 would be pi over 3 plus pi. Just a word of advice, if you get hung up on these fractions, you can use your calculator, but don't do the pi. Just do like 1/3 plus 1, and then tack the pi back on your answer. So it's sine of 4 pi over 3. Okay, what quadrant is 4 pi over 3 in? Third. Reference angle?
60.
Yep, pi over 3 is 60 degrees. So, in the third quadrant, sine is negative. Sine of 60, radical 3 over 2. I get negative 2 radical 3. This okay with everybody? Okay, technically, we are at the end of the section. This homework is not going to be due until Thursday. Tomorrow we are going to practice filling out the circle again. We're going to go over a few more things, but you know everything you need to do the homework. You will have some class time tomorrow to work. Does everybody know what I mean when I say EOE? Every other even? Okay, just making sure. There's always somebody that does all of them.